A cell of EMF 1.5 volts is connected to a wire of length 120 centimeters and the resistance is 4 ohms. Find the potential difference across 30 centimeters of the wire. So we are only required to find potential difference across a portion of that wire. The wire is 120 centimeters. We need to find potential difference just across 30 centimeters of this whole wire. And the condition here is that if the EMF here, this cell whose EMF is 1.5, is having an negligible internal resistance. So let's draw the diagram of this and get started with the working. Now here we are having this cell. It's 1.5 volts. It is connected to a wire, and this wire, the length of this wire is 120 centimeters. So meaning that the length here is 120 centimeters. It's connected in that kind of circuit. And the question is requiring us to find the potential difference across 30 centimeters of the wire. So if the distance from here to here is 120, we are being required to just find the potential difference or the output voltage of the wire just 30 centimeters. But we know that this whole length is corresponding to, this whole thing has 4 ohms. So again, like before, to get this potential difference V, or the portion here, it means that we need to find the current going through that portion times the resistance of that end. So to get the output, V naught is going to be equal to I times R. By I, we are seeking to find the amount of current that is flowing through that portion, which we do not have yet, and the resistance of that portion, which we are still supposed to find. So let's first begin with the current. So the current that is going through this portion of the wire, let's call it IS. So meaning that current IS is going to be equal to V over R. V is 1.5. Divide that by the effective resistance in this whole circuit. The effective resistance is 4 ohms. The internal resistance here is negligible, so we only have 4 ohms. So it's 1.5 divided by 4, and 1.5 divided by 4 is going to give us 0.375 amperes. So it means that the amount of current flowing through here is 0.5 amperes. So now what about the resistance of that portion of the wire? Because we are required to find the potential difference across that portion of that wire. Remember, earlier again I said that since we do not have, remember again earlier we said that since remember earlier I said that voltage, I said that resistance is directly proportional to the length. Now the length of this whole thing is 120 centimeters, and we only need a portion of it, which is 30 centimeters. We have the resistance of the entire length, which is 4 ohms, but we do not know the resistance of that portion. So let's try and find the resistance of this portion. Since we know that R, or the resistance of the wire, is directly proportional to the length of the whole wire, we can find the corresponding resistance of that portion of the wire, so that we are able to put it right there, because it's what we are interested in. So to find the corresponding resistance of that portion of the wire, we shall say that 120 centimeters is equivalent to 4 ohms. So what about these 30 centimeters? What resistance will it be corresponding to? Let's call it X, and we find the value of X. When we cross multiply, we shall end up with X being X times that is 120. X is going to be this times that, which is 30 times 4. Divide by 120, divide by 120. And we shall end up with 30 over 120. This is actually the fraction of the wire times the total length. We shall find that this portion of the wire is just 1 ohm. So here we have the current going through that portion of the wire, which is 0.375 amperes, and we also have the resistance of that portion of the wire, which we have found to be 4 ohms. Now we can go ahead and find the output voltage of this portion of the wire, which is the current, which is this, times R, which is 1, which is 0.375 volts. And that's the answer. So now we're going to repeat this question. Part B is telling us that find the PD across the 30 centimeter of the wire if it has 1 ohm as internal resistance of the cell. So the internal resistance here is 1 ohm. That's a slight change in the question. So if I may redraw this circuit diagram, it's still going to be this. Now this time around, this cell, they are telling us it has 1 ohm internal resistance. So it's having an internal resistance here of 1 ohm. This whole thing is the cell. So again, just like before, to get the output voltage V0, for us to get the output voltage, we know we need to find the current that is going through this portion of the wire. The 30 centimeter portion of the wire, we already found out that it is 1 ohm. So this is 1 ohm, the rest of this is 3 ohms, this portion of the wire. So this is 1 ohm, yeah. And now we need to find the current times the effective resistance. Times the resistance, which is 1. Now we need to first find the current. Let's do some work here. The current, which so happens to be the source current here, is going to be equal to the potential difference V divided that by the effective resistance in the whole circuit, which is going to be capital R. Now this so happens to be the effective, the V here, this thing is 1.5 volts, according to our question. So the EMF, or the potential difference, 1.5, divide that by the effective resistance in the whole circuit. Now in the circuit we are having this resistance, which is 4 ohms of the whole thing of this. But remember that our cell is having an internal resistance of 1 ohm. So it means we treat this internal resistance as though it is a resistor that is in series with the rest of this. So it means that our effective resistance in the whole circuit is going to be this entire 4 ohms, add it to that 1 ohm resistor. So it's going to become 1.5, divide that by 5, and definitely 1.5, we'll end up with 0.3 amperes. So now that we know that the amount of current going through here is 0.3 amperes, it means that the output voltage therefore is going to be 0.3 amperes multiplied by that resistance, which is 1, and it is going to give us 0.3 volts. So that is the output voltage, or the voltage across the portion, or the PD across the 30 centimeter portion of the wire. And that answers our question. Now, of course, if you may want to use the formulas that we derived earlier in our general terms, or in the general sense, this would mean, now if I am to use this formula, in this case, it would mean that I'm going to say V0, output voltage, is going to be R2 over R1 plus R2. Now our R2 in this case is the resistor that is across the output voltage that we want. So in this case, the resistors that is across the output voltage that we want is 1. Divide that by the effective resistance in the whole circuit. Now in this case, the effective resistance in the whole circuit is going to be this resistor here, which is 1, plus 3, plus that other resistor, which is 1. And then we multiply that by Vs, and Vs is the source voltage. And in this question, our source voltage is 1.5 times 1.5. And definitely we shall be able, when we compute that, we still get the same answer of 0.3 volts. Again, if we were to use this approach in our first question, it would still be the same approach, only that this time around, our value of R2, it's still going to be 1 over R1 plus R2. Now in our first instance, remember, this 1 ohm was not included. It was not part of the deal. So it means that in our calculation, in the first instance, this one would be excluded, and would continue doing our question like before, and would still get our answer.